In the last two episodes, we explored how bias can appear in the earliest stages of AI, before it's even built, and then during its development and training. But there is still one more stage where bias can quietly slip in. After the model is created, when it enters the real world. To keep things concrete, we will stay within the world of healthcare, a place where bias isn't just a data problem, but a life problem. So let's take a moment to imagine the journey of a medical AI. It starts in the lab, where it's built. Then it moves to the hospital, where it's used. Finally, its results are written about and shared in research papers. And at every step of that journey, something subtle but powerful can creep in: bias. Even if the data itself is fair, bias can still emerge in how the AI is deployed and described. Let's unpack how that happens and why it matters. First, bias in model development and evaluation. Building an AI is a bit like baking a cake. Every ingredient, every choice, every small adjustment affects the outcome. Developers decide what data to include, which algorithm to use, and how to test if it works. But those choices are not neutral. They can quietly tilt the result. For example, imagine testing your AI only on clean, perfect data, neatly organized medical records from one big city hospital. It looks great in the lab, 95% accuracy. But when it's used on real patients, older adults, kids, people from smaller towns or minority backgrounds, it suddenly stumbles. It's like training a GPS using only city roads and then wondering why it cannot find its way in the countryside. Another trap hides in how we measure success. If a model is 95% accurate overall, that sounds impressive. But what if it's twice as likely to misdiagnose women or black patients? When we only look at averages, we miss who's being left behind. So how do we fix that? By testing AI on diverse groups, using fairness-focused metrics, and making sure the system's decisions are understandable, not a mysterious black box. Because in medicine, almost right isn't good enough when someone's health is on the line. Second, bias in deployment and implementation. Now let's step out of the lab and into the hospital, where real life begins. Even the smartest AI can falter once it meets the messy, unpredictable reality of clinical work. Imagine an AI that was trained in Hospital A using one brand of MRI machine. It performs beautifully there. But when Hospital B installs it, using slightly older machine or treating a different population, the model starts to make mistakes. The bias didn't exist in theory. It appeared in practice. And the humans matter too. Doctors might trust the AI more with certain patients than others. Some may over-rely on it, while others ignore it altogether. To reduce this inconsistency, AIs should be tested in multiple hospitals before launch. Their performance should be monitored continuously. Doctors and staff should receive training on how to use them consistently. And AI systems should be flexible, able to adapt to new settings, not crumble outside the lab. Healthcare isn't one size fits all, and neither should AI be. Third, bias in publication and reporting. Finally, there is a quieter but equally important kind of bias, the kind that shows up long before the AI reaches a patient. Publication bias. Here is how it works. Researchers are human, and humans like good news. So when an AI performs well, it gets published. But when it fails, especially for certain groups, that story often stays hidden. The result? the scientific records start to look far more optimistic than reality. Without that transparency, others might build on flawed assumptions, unknowingly repeating the same mistakes. It's like watching only the highlight reel of a sport game and thinking your team never loses. To fix this, we need openness and honesty. Publish all results, not just the shiny ones. Report performance by group, not just in total. And make sure the teams designing AI include ethicists, clinicians, and community voices, not just coders or engineers. Because fairness isn't automatic, it's a choice. So when we talk about bias after development, it's not just about bad code or flawed training dataset. It's about how technology interacts with human systems, hospitals, people, institutions, each with their own habits, blind spots, and priorities. AI doesn't exist in a vacuum. It learns from us, reflects us, and if we are not careful, repeats our mistakes. I am Ehsan Erzurumchilar, a researcher of technology, and I invite you to join me in exploring how technology transforms our sense of what it means to be human.